To create a hexagon grid system in the pointy top orientation, first, create a blueprint actor and add a single component called an instant static mesh. Next, create variables to store the 2 radii and 2 diameters of a hexagon. We also need variables to store the height and width of our hexagon grid, as well as the row offset so the hexagons slot evenly with each row or column. Create a variable to store the static mesh of the hexagon you'll be using, and make sure the flat side of the hexagon is oriented along the y-axis. Optionally, create variables to store the offset and scale values if you want to adjust your grid spacing. Make sure to set your scale value greater than 0 so your grid will at least show up. Now, create 4 functions called calculate sizes, vertical space, horizontal space, and offset hexagons. The calculate sizes function should take the static mesh variable and get the bounding box values from it. You will need to split the pins until you have access to the max x and max y values and multiply these against your scale variable. Then pass the y result to your small radius and your x result to the large radius. You can multiply the radii by 2 to get the 2 diameters. The vertical space function should take the width value and multiply it against the large diameter multiplied against 0.85. Then add this to the result of the width value multiplied against the offset and pass that result to the output pin of the function. The horizontal function should take the height value and multiply that against the square root of 3 multiplied against the small radius. You can then add this to the result of the height value multiplied against the offset, and then pass that result to the output pin of the function. Next, your offset hexagon function should simply take the small radius and multiply it against -1, and set the offset or the row offset variable value to that value. Finally, we can write our construction script. It should use the set static mesh node and target the instant static mesh component we created earlier. We can pass the static mesh variable into the new mesh pin. Then call the calculate sizes function to populate our radii and diameters. Then call our first for loop with the index starting at 0 and ending at the height value. Then call the horizontal space function into our second for loop, which will start at 0 and end at the width value. Pull this into the vertical space function and then add it into the add instance node. Split the transform pin to have access to the x and y values. The vertical space return value will be added to the y value, and make sure to add your offset in as well. The horizontal space return value will feed directly into the x value. Then pass your scale into the add instance node as well. On the second for loop, pull off the completed pin into a flip-flop node, with A going into your offset hexagon function, and B going into a setter node for the row offset value, which should be 0. And just like that, you have a completed hexagon grid system in the pointy top orientation style. Enjoy.